My research focuses on the endpoints of stellar evolution. So stars like the sun, they're constantly burning hydrogen in their cores, turning it into helium and producing energy. They can only do this for so long. Eventually, all of the hydrogen in the core becomes helium, and at that stage, the star has to expand, starts fusing helium together instead, gets a lot bigger, and turns into a red giant. And then after that, the outer layers of the star are cast out into the surrounding space, and what's left over is a dense core of very hot leftover material. And these dense cores, we call them white dwarfs because they're so small and yet so hot. So typical white dwarfs tend to have a mass about the same mass of the sun, so really, really heavy, maybe about, I think, 300,000 times more mass than the Earth, but they're only the size of the Earth. So these really dense, really exotic objects. So that's one of the endpoints of stellar evolution. The other ones are neutron stars and black holes. So more massive stars in the sun, when they get to the end of their lives, rather than just shaking off their outer layers into the surrounding space, they instead undergo an explosion, really powerful explosion. We call these supernovae. And these supernovae, if you have a star that's maybe 8 to 15 times more massive than the sun, so quite a heavy star, it'll produce a neutron star at the end of its life. This is a really dense object, rotating really quite rapidly. They again have about the mass of the sun, but now they're the size of Cork City. Really, really dense objects going more extreme than white dwarfs do. And finally, the most massive stars, when they get to the end of their lives, they completely disrupt space and time, and they produce what we call a black hole. So it is the fate of all stars in the universe to end their lives as one of these three types of objects: white dwarfs, neutron stars, and black holes. So understanding these objects, how they form, how they evolve through their lives, and how they interact with other stars that they come across in the Milky Way is important for us in understanding, well, what is the final fate of the sun going to be? So neutron stars within the Milky Way, and this has been performed by people already, can be used to accurately tell where you are in the Milky Way, and also possibly in the future communicate that to other species in the galaxy. If there's aliens out there, we can tell them where we are by referencing all of the neutron stars that we're seeing within the Milky Way. There's also an inquisitiveness that, these objects, these black holes, these neutron stars, these white dwarfs, they evoke a certain curiosity in everyone's minds. Whenever you say the word black holes, you can see people just immediately becoming interested in what even is that? And it's part of human nature to chase these questions, to be curious about the things that we don't understand. So that's why I think this sort of research is incredibly important, because we're driving forward humans' knowledge of, well, how does the universe work? How does everything evolve? Where is the universe going?